2t minus pi sine t, and y equals 2 minus pi cosine t. So that graph you're looking at over there is the result of these two parametric equations. Find the equations of both tangent lines at that point 0, 2. In other words, this point 0, 2, we want the equations of the tangent lines. Okay, so if we go through the analysis that I went through trying to find dy dx, we get dy dt, which is pi sine t, over dx dt, which is 2 minus pi cosine t. You with me?
Yeah.
This is dy dt, and this is dx dt.
Okay, yeah.
So we have dy dx at that point 0, 2 is equal to minus pi over 2 when t equals minus pi over 2, and it's dy dx is equal to plus pi over 2.
How did you get negative pi over 2?
I'll tell you in a moment here. Let me just write it out. All right, their logic here is because at the point x equals 0, y equal 2, when t is equal to plus or minus pi over 2. Let me think.
So did you just plug in a number on the unit circle to make it have a nice number?
No, I plugged in this number right here.
So you plug in 2.
For x and solved it. In other words, when x equals 0, 2t minus pi sine t has to equal 0. And that happens when t is, and y is 2. In other words, if I plug in y is 2 into the original parametric equations and solve these right here for t, I get those are both true when t is plus or minus pi over 2. Let's see, the pi over 2 comes from solving this t here. It's not trivial to solve that. Right there?
Why?
Well, because how do we solve it? Let's erase our answer here. So 2t would be equal to pi sine t. How do you solve that?
You divide. No, you can't do that.
Can't do that. One way to solve it is to put it on Wolfram alpha and wherever they intersect. And they intersect at pi over 2. And this one, the y, is true. Actually, we can solve this one over here, can't we? Yeah, let's solve the other one first. We have 2 equals 2 minus pi cosine t. So minus pi cosine t has to equal 0. And that happens at t equals pi over 2. fact, it happens when t is equal to plus or minus pi over 2. If you take the cosine of negative pi over 2, you get 0. If you take the cosine of positive pi over 2, you get 0. So that's how we got where this point occurs. I actually didn't have to solve the x for t, but I'm sure that that also would give me pi over 2, would it not? Yeah, because then pi equals pi. So if I knew how to solve the x one, I would have gotten pi over 2, plus or minus. And when I solve the y one, which I can solve relatively easy, I get this point happens when t is plus or minus pi over 2. Okay, so what does that mean? That means that, okay, our dy dx was this. We're saying that that dy dx is equal to minus pi over 2 when t is minus pi over 2, and it's equal to pi over 2 when t is pi over 2. So the two slopes of our tangent lines are pi over 2 and minus pi over 2. In other words, because of this, if I solve dy dx at the two critical points, which are plus and minus pi over 2, so if I substitute plus pi over 2 into this derivative here, in other words, I'm evaluating it at a certain t value. So it's similar to your problem. Your problem was we had to find the slope at a certain t value of 2. Well, in this problem here, we had to figure out what the t value was when this point occurs. What is t when x is 0 and y is 2? Well, t is two different things. It's plus or minus pi over 2. So now, to figure out the slope, I have to plug plus pi over 2 into that and minus pi over 2 into that. And when I do that, I get these two slopes. So those are the two slopes of my tangent line. And the next step is to use the point slope formula. Since I have the slopes of my tangent line, well, I know that the point slope formula says y minus 2 equals minus pi over 2 x, and y minus 2 equals plus pi over 2 x. So there's the two equations of my tangent line. Notice that at no spot do I have to define a x of t. Do I? And anywhere in this problem, did I have to define x of t? Which is what they want you to do on your problem. So what could they be talking about here? They want, I guess one thing I don't understand particularly is why this isn't the same. For the line x of t, you tried putting in that answer, 6t squared plus 3. It wouldn't make sense to ask the question is what I'm confused about.
No, I didn't try that one. You can, though.
Well, let's try it, just because we're kind of lost here. 6t, I just can't imagine that this is correct.
Yeah, that'd be weird.
It would be weird. Okay.
Do you think Wolfram alpha does parametric equations?
They do, I'm sure, but let's try it. Maybe they will give us an x of t.
We just need to figure out what we're doing wrong.
I know. We need an example. In other words, we need them to show us how they want us to do it, and then we can figure out how to do it. But my book does not have this example. So let's see. We're going to put in yours, right? So I've got x of t equals 6t squared plus 3. Let me put that in. X equals 6t squared plus 3. X equals 6t squared plus 3, comma, y equals 5t cubed.
Parametric.
Now it should recognize it as a parametric equation.
Yeah, parametric plot.
Okay.
Real solution.
See, it's just telling us the same thing we put in.
Do you think we have to put them in the other slot or the other space? Like put 6t squared plus 3 in the y answer? Or would that be wrong?
I don't see how that could make sense, but actually the way we came up with that first answer I kind of liked. Did we potentially just make a math error? When we came up with this answer here,
Yeah, I'll be right back. 1 second, I can go to the bathroom.
we need a function of x. We need x to be a function of t, but I don't get the question. Why? Find the parametric equations for the tangent line. So, okay, what we found was the xy equation for the tangent line. What this is here is the what I have circled here. That is the xy equation for the tangent line. Okay, I think I know what to do. I think I got it understood now. What we need to do is plug in 5t cubed for y. And then we will have x as a function of t. And we'll plug in this for x, and we'll have the function y. Yeah. This should work. Okay. Let's see what we get here. We're going to start with plugging in y, which is 5t cubed. So we have 5t cubed minus 40 equals 5 halves x minus 27. If we solve that for x, we should have what they're looking for. So we have 5 halves x, oh my god, minus 135 halves equals 5t cubed minus 40.
Okay.
So we have 5 halves x equals 5t cubed minus 40 plus 135 halves. Multiply everything by 2 for starters. 5x equals 10t cubed minus 80 plus 135. X is going to equal 2t cubed. What is that? That is plus 55 divided by 5. So plus 11. There's our answer. almost positive that's the way to do it. I may have made a math error, so it may not be right. Let's see, it's 2t cubed plus 11.
If
I preview that just to make sure, okay. Bet you this is right. Oh, gosh. How can that not be right?
Look at the next problem. You know how to do that one?
Write the parameterization for the curve in the xy plane that is a vertical line through the point -3, -1.
So you have to write the parametric equations for the curve.
Yeah. Shouldn't be too hard to figure out. So we have a vertical line going through the point -3, -1. Now the equation of that line is x equals -3. So how would we do this? We know the slope is undefined. I don't even have an example of this. This actually doesn't look like a calculus problem here. This looks like a straight parametric. I do not know how to do this. I'm trying to figure out in my head how we could do this. How do you parameterize that? Must have to do with the fact that it's a vertical line which has a slope of infinity. How the heck do we work backwards from that is the question. In other words, dy dx is undefined. I'm trying to think if I can make up a parametric equation that defines this vertical line. What would it be? X would be a function of t. So x is always going to be -3 Sorry, Michael, I don't know how to do this one either.
It's okay.
Should we look at problem 3? Maybe we'll find one I know how to do. The line is parameterized. Which of the following points on the line obtained by restricting t to non-negative numbers if the point is on the section and n if not? So they're asking us if these 3 points are on the line.
Like the intersecting
minus,
part of the line?
well, if we let, in other words, parametric equations are not just two equations like this. You also have a domain for t. T isn't always just all real numbers. Sometimes t goes from like -5 to -2. If we restrict t to just positive numbers, then can we get an x of -3 and a y of -10? I'd say no. For that one, can I submit just that?
Yeah.
Hey, I got lucky. Okay. Can we get 17 and 25? Well, with a positive t, I don't see why. Let's see. Can we get 17 for x? 17 equals 5 plus 4t. So t would be 3. And 25 would have to equal 4 plus 7 times 3. And it does. So we can get this point here on our curve. You see what I'm doing?
Yeah.
Okay.
You're just setting them equal and seeing if the...
Yeah, seeing if that's correct. Okay, now we just have to try the third point. So 25 equals 5 plus 4t. T is equal to 5. So is 39 equal to 4 plus 7 times 5? Yes, it is. How could their other problems be so hard and this one's so easy? The problem is those other problems are not hard. That's our problem, is we just don't know how to do them. I don't know their technique, what they're looking at. It would be wonderful if this thing had an example that it could show you when you don't know how to do it, because then we could learn how to do it. It's one of my complaints about some of these computerized things. Okay, give one more point that is on the section of the line obtained by this restriction. Well, that's easy. What should we do?
I don't know how to do that one.
Well, we want to find another positive t value. We just looked at t equal 5 and t equal 3. Let's try t equal 4. Well, what's x when t equals 4? X is 16 plus 5, 21. And y when t equals 4 is 4 plus 28, 32.
32.
So 21 comma 32. Your answer isn't a point?
Bring it to just one number.
Maybe they want t. Give one more point that is on the section of the line. I need parentheses.
Parentheses.
I didn't put parentheses on it. That's another thing I hate about these problems.
Yeah, online math homework's just weird.
It's very, very weird on these computerized. I've run into problems before, not quite like I have with you, With you, my problems is that my textbook doesn't ask those kind of problems and doesn't give those examples. So it's hard for me to figure out what they want. Okay, what are the endpoints of the line segment obtained by restricting t to -5 to -2? Well,
What are the endpoints from the line segment of t?
yeah, what are we going to do here?
Plug in -5, -2 and a point. Or just
Plug in -5 first.
yeah.
The endpoints are going to come when t is at -5 and t is at -2. So when we plug in -5, what do we get for the left endpoint? We get -15. And what do we get for y?
It's -35 plus 4, -31.
-31, parentheses. Shall we check that answer first?
Yeah. Okay.
In the right endpoint, we just need to plug in -2 for t. So that becomes -3 and -10.
-4, -10.
-10. That was that point up here that they wanted to know was on that curve. It was on the curve, but not when t was restricted to positive numbers. How should t be restricted to give the part of the line to the right of the y-axis?
Okay, well, I have to go to class now.
Okay.
Here.
The answer to this one is just find where x is positive only.
How would I do that?
Well, you could graph the line, solve each of these for t, set them equal to one another, so we'll have the xy equation for that.
Okay.
And then look at the line where it's to the right of the y-axis. In other words, wherever x is positive. And then we have to figure out what that point is and what that value of t is. Right off the hand, it looks like t would have to be, t is going to be positive whenever, or x will be positive whenever t is minus 5/4 or greater. T must be n, I don't know. If you have to run it, I'm going to have to look at this a little bit more. How should t be restricted? So t has to be from something to something. They're looking for a t like this. Obviously, when t was between -5 and -2, we were to the left of the y-axis. And when t was positive numbers only, we were to the right of the y-axis, but it maybe doesn't have to be positive numbers only. In other words, if t is minus 5/4, x is 0. So play around with that for that last part.
All right, yeah, so I have to go to class, but scroll up really quick.
Okay?
And click on Math 1300 Spring 2014. Like,
Right here?
that? Yeah.
Yeah.
And then section 5.1 is what me and you will do next time.
Okay.
I'm going to set up a session with you over like tomorrow or Saturday.
Okay. So will I have some time right now that I can look at 5.1?
Yeah, if you can stay logged into that, and you can write down my my password and username. So I got to go to class, so.
Okay. I'll talk to you later. I will put this.
Just text me if you have anything to tell me, and I'll set up an appointment for tomorrow or Saturday.
Okay. Sounds good.
All right. Thank you.
All right. Bye-bye.